Good morning. I am Dr.Remila, Assistant Professor, Science and Humanity Department, Emmanuel RSF JJ College of Engineering. Now we discuss about the topics are motions, oscillations and lasers. First of all, I explain about motion and its types. Next, I am going to explain about oscillations and its types. Finally, the laser. Okay, what is motion? When the position of the body in the space changes with the time, the body is said to be motion. What is motion? When the position of the body in the space changes with the time, the body is said to be motion. What are the types? It is classified into 4 types. The first one is the translation motion, rotational motion, periodic motion, finally oscillatory motion. First, I discuss about the translation motion. What is translation motion? If a position of a body varies linearly with the time, then the motion is said to be translation motion. This image represents the example of the translation motion. A car or train moving on a straight road. Next example is a ball moving on the ground. These are the examples. The next one is rotational motion. This image represents the rotational motion. The examples of rotational motion is motion of earth about its axis, then the rotation of a flywheel on its ball bearing. These are the examples. Okay. What is the definition of rotational motion? If the position of a body as a whole does not change linearly, but it rotates at the same position about an axis, then the motion is said to be rotational motion. The third one is the periodic motion. The periodic motion, the best example is the motion of the pendulum, the oscillations of the loaded string, motion of the planets around the sun. Okay. If the definition is, if a body repeats its motion at regular intervals of time, its motion is said to be periodic motion. The body repeats its movement at a regular interval of time, the motion is said to be periodic motion. Finally, oscillatory motion. This image represents the examples of the oscillatory motion. The motion of the pendulum, one example. Next example is the oscillations of the loaded spring. This example is known as the oscillatory motions. What is the definition? An oscillatory motion is one in which the body moves to and fro repeatedly about the mean position. This is oscillatory motion. Okay, next topic, oscillation. What is oscillation? What are the types? Okay, a repeated back and forth motion or fluctuation of the system around the equilibrium position. This is oscillation. Types: free oscillation, damped oscillations, forced oscillation. First, explain about the free oscillation. The free oscillations, the best example is the vibrations in a tuning fork. This image represents the vibrations in a tuning fork. When a body is replaced from its equilibrium position and then released, it oscillates under the influence of restoring force with a definite frequency. Such vibration is called free vibration. The examples: oscillations of the simple pendulum, sound produced by tuning fork in a short distance. Okay, next one is damped vibration. This image represents the examples of damped oscillations. The first one is the weight on the spring, the oscillations of the pendulum in air. These are the examples. The oscillation that decreases with time is called damped oscillation. The oscillation that decreases with time is called damped oscillation. Forced vibration. This image represents example of forced vibration. When a body oscillates with the influence of an external periodic force, it is called as forced oscillation. The examples are sound boards of string instruments suffer forced vibration. Swing can be kept in motion by giving constant periodic forces. This is example of forced vibration. Okay. Finally, the topic is laser. What is laser? Laser stands for L means light, A means amplification, stimulated S, E means emission, R means radiation. Okay, laser stands for light amplification, stimulated emission of radiation. A laser produces a highly intense, then single color and focused beam of light using the process of stimulated emission. These are the laser produce highly intense, single color and focused the beam of light. This diagram represents the laser principle. Okay, the pumping, this is the active medium, it is the two mirror, up and down two mirror, finally the laser beam is get out. What are the principle? When an atom is excited to a higher energy level, when an atom is excited to a higher energy level, it remains there for a short time. If a photon of suitable energy strikes this excited atom, it stimulates the atom to return to a lower energy level. The emitting of second photon that is identical to the first. The both photons have same frequency, same phase, same direction, same polarization. The photons have same frequency, same phase, same direction and same polarization. This is the principle of the laser. Then next explain about theory of laser. Theory of laser. The first one is the stimulated absorption. Stimulated absorptions. This image represents the absorption process in laser. First, before absorption. The next image is after absorption. Okay. Atoms in a material. Atoms in a material absorb the energy. This is the E1 means the lower energy level, E2 means the higher energy level. The atom is situated in a lower energy level. This is the before absorption. Next one is the after absorption. The atoms in a material absorb energy. When atom absorbs the energy, it moves from a lower energy state to the higher energy state. Higher energy state. It is means the excited state. The atom is moving to the excited state. This is the stimulated absorption. E1 means lower energy state. E2 means higher energy state. The higher energy state means in the excited state. The lower energy state means in a ground state. Okay. The atoms in a molecule, when atoms absorbs the energy, it moves from a lower energy state to the higher energy state. Okay. The principle, working principle. An atom absorbs energy and moves to an excited state. A photon with the correct energy strikes the excited atom. The excited atom emits another photon identical to the incoming photon. Both photons travel in the same direction with the same frequency, same phase, same wavelength and polarization. What are the principle? What are the principle of another absorbance, stimulated absorption? When an atom absorbs the energy to the lower energy state to higher energy state, a photon with the correct energy strikes the excited atom. The excited atom emits the another photon identical to the incoming photon. Both photons travel in the same direction, same phase, same wavelength, same frequency, same polarization. Okay, the characteristic. The first point is produces two identical photons. Correct. First point is the produces two identical photons. Next point is emitted photons are same phase, coherent. Coherent. What is coherent? Coherent means the emitted photons are same phase. Okay, the phase is same. Light is highly directional. Light is highly directional. Then amplifies the intensity of light. Amplifies the intensity of light. Forms the basic principle of laser operation. Forms the basic principle of laser operation. The first one is the stimulated absorption. This is the principle. Then this is the characteristic. Then application. Lasers are used in medicine field. Specifically, it is used in eye surgery. Okay. Then it is used as the optical fiber communication. Next, used in industrial cutting and welding. Industrial cutting and welding, it is also used. Barcode scanners. The laser is used as the barcode scanners. Then finally, laser used in holography and scientific research. These are the applications. Okay, next one is the spontaneous emission. This diagram represents the first one is the before emission, the last one is after emission, the center image is during the emission. Okay. What is spontaneous emission? The spontaneous emission is the natural process in which an excited atom or molecule returns to a lower energy state by emitting a photon without any external stimulation. Spontaneous emissions means no external stimulation. Only the spontaneous emission is the natural process in which the excited atoms or molecules return to lower energy state by emitting of a photon without any external stimulation. This is the definition of the spontaneous emission. This is before emission. The last diagram represents the after emission. The center image represents the during emission. Okay. There is no external stimulation. Working principle. An atom absorbs energy and moves to an excited state. It remains in the excited state for a short time. The atom naturally returns to the ground state. The atom naturally returns to the ground state. During this transition, it emits a photon with the energy equal to the difference between two energy levels. Working principle: an atom absorbs energy and moves to an excited state. It remains the excited state for a short time. The atom naturally returns to the ground state. During this transition, it emits a photon with energy equal to the difference between the two energy levels. Next, characteristic. What are the character? The spontaneous emission of the characteristic. No external photon is required. No external photon is required. There is no need of external stimulation. The emission occurs randomly. Emitted photons have random direction, phase, and polarization. Emitted photons have random direction, phase, and polarization. That produces a incoherent light. Coherent means same phase. Okay. Incoherent means not the same phase. Does not amplify light. Then application. Fluorescent lamps. It is used as fluorescent lamp. It is used as LEDs. This type of laser is used as the natural light emitted by stars. Glow discharge lamps. Okay. Spontaneous emission. What are the spontaneous emission? There is no need of stimulated force, any external stimulated force. The spontaneous emission is a process in which the excited atom or molecule return to a lower energy state by the emitting of photon without no external stimulation. Then principle. An atom absorbs the energy and moves to an excited state. It remains in the excited state for the short time. The atom naturally returns to the ground state. During this transition, it remains a photon with energy equal to the difference between the two energy levels. This is the characteristic. This is the application. Next one is the stimulated emission. What is stimulated emission? E0, this graph represents E0 means ground state. E1 means higher energy state. E0 means lower energy state, ground state. E1 means higher energy state. H means incident energy of photon. The atom is in the E1. E1 means higher energy state. This is the before emission. The last one is the after emission. Atom is in the lower energy state. Atom is in the lower energy state, E0. During this transition, The incident energy of photon, the incident energy of photon, this causes the excited atom or molecule release a second photon of the same energy. This is called stimulated emission. What are the principles? The stimulated emission is the process in which an incoming photon causes an excited atom or molecule to release a second photon of the same energy, same phase, the direction and polarization as the incoming photon. This process is the fundamental principle behind the laser. How it is work? How it is work? Another stimulated emission. The first point is an atom absorbs energy and moves from ground state to the excited state. An atom of energy moves from the ground state E1 to excited state E2. While the excited state, the photon with energy equal to the energy difference E2 minus E1. E2 minus E1 means while the excited state, a photon with energy equal to the energy difference. E2 minus E1 means energy difference. E1 means ground state. E2 means excited state. The incoming photon stimulates the excited atom to return to the ground state. The incoming photon stimulates the excited atom to return to the ground state. The atom emits the second photon that is identical to the first. The atom emits a second photon that is identical to the first. Thus, after the interaction, there are two identical photons. There are two identical photons traveling together. There are two identical photons traveling together. How it is work? Stimulated emission. The stimulated emission is atom absorbs the energy to move to the lower energy state to higher energy state. While the excited state, a photon with energy is equal to the energy difference E2 minus E1. The incoming photon stimulates the excited atom to return to the ground state. The atom emits a second photon that is identical to the first. Thus, after the interaction, there are two identical photons traveling together. Energy relation. What are the energy? The energy of the emitted photon E equal to h nu. The energy of emitted photon is E equal to h nu. H nu equal to E2 minus E1. E2 minus E1 means in the energy difference, where h is the Planck constant, nu is the frequency of photon. H is the Planck constant, mu is the frequency of photon. This is the energy relation. The energy emitted the photon is E equal to h nu. H nu means E equal to E2 minus E1. E2 minus E1 is the energy difference. H is the Planck constant, where H is the Planck constant, nu is the frequency of the photon. The characteristic of the stimulated emission. Emitted photons has the same frequency as incident photon. Emitted photons has the same frequency as incident photon. Travels in the same direction. Is in phase with the incident photon has the same polarization. What are the characteristics of stimulated absorptions? What are the characteristics of stimulated absorption? Emitted photons has the same frequency as incident photon. It travels in the same direction in phase with the incident photon. Has the same polarization. This is the characteristic. What are the importance? It produces coherent light. It is the working principle of a laser. It enables light amplification because one photon effectively becomes two identical photons. These are the importance. What are the importance? It produces the coherent light. It is the working principle of laser. It enables light amplification because one photon effectively becomes two identical photons. The stimulated emissions. The stimulated emission is the process in which the incident photon induces an excited atom to emit another identical photon, resulting in the amplification of coherent light. These are the importance of the stimulated emission. The first one is the laser explained about the spontaneous emission. Spontaneous emission, stimulated absorption, stimulated emission. Okay. The spontaneous means the spontaneous emission is the process in which the excited atoms or molecules return to the lower energy state by emitting a photon without the external stimulation. This is the spontaneous emission. E0, E1 means lower energy state, E2 means in a higher energy states. This is the spontaneous emission. Next, the characteristic, the spontaneous applications of spontaneous emission. It is used in the fluorescent lamp, LEDs, finally natural light emitted by the stars. Next one is the stimulated emission. Stimulated emissions, the atom is in the higher energy state. Hd photon is incident on the higher energy state. The atom is moved to the higher energy state to the lower energy state. This is stimulated emission. This is the principle how it is work. Stimulated emission. This is the energy relation. Energy relations means equal to h nu E2 minus E1. H is the Planck constant, mu is the frequency of the photon. Next one is the characteristic of stimulated emission. It is travel in the same direction, is in the phase with the incident photon, has the same polarization, same frequency. These are the characteristic of stimulated emission. Importance. It produces the coherent light. It is the working the principle of laser. It enables the light amplification because one photon effectively becomes two identical photons. These are the stimulated emission. Now recall the first topic. Oscillations. What are the oscillations? Oscillations is repeated back and forth motion or fluctuation of the system around the equilibrium position. The types are free oscillation, damped oscillation, the forced oscillations. Free oscillations, the best example is vibrations on the tuning fork. These are the free oscillation. Damped oscillations, it is the best example is the oscillations of the pendulum in the weight on a spring. These are the examples of damped oscillation. The forced vibration means the examples are sound boards of stringed instrument suffer forced vibration. This is the best example of forced vibration. Um, this is the another one example is the swing. The swing can be kept in the motion by giving constant periodic forces. Is called a forced vibration. Next one is the laser. Laser stands for light amplification stimulated emission of radiation. This is the laser principle. The types, the theory of laser types: stimulated absorption, spontaneous emission, the stimulated emission. Okay. Applications: spontaneous emission, working principle, characteristic. Next one is the stimulated emission. This is the principle of stimulated emission. How it is or the process. The atom absorb energy, moves from the ground state to the excited state. The energy difference is E2 minus E1. Energy relation E equal to H nu E2 minus E1. This is the characteristic of stimulated emission. It is the important. What is the important? It produces coherent light. Working principle of the laser enables the light amplification. These are the importance. The stimulated emission is the process in which the incident photon induces an excited atom to emit another identical photon, resulting in the amplification of coherent light. Okay, thank you.